In this video, we're going to take a look at the combined gas law. So the combined gas law really is just all of the gas laws. So Boyle's, Charles, and Gay-Lussac's law combined together. And so the equation we get from that is P1V1 over T1 is equal to P2 V2 over T2. And so the ones, let me just fix this here. The ones represent our initial conditions, and then our twos all represent the final condition. So if we have pressure, volume, and temperature changing, we can still solve problems involving those scenarios. Let's then take a look at an example. So we have 12.0 decimeters cubed or liters of a gas is at SATP. So remember, this is 25 degrees Celsius and 100 kPa. What would the volume be? So we're looking for volume at 0 degrees Celsius and 50.0 kPa. A good place to start is to list out what we know. So V1 is 12.0 decimeters cubed or liters. T1 is our temperature at SATP, which is 25 degrees Celsius, or putting that into Kelvin, that's 298 Kelvin. And our P1 is standard ambient pressure, which is 100 kPa. And then our final conditions, V2 we don't know. T2 is 0 degrees Celsius, or that's also 273 Kelvin. And finally, P2 is 50.0 kPa. We can then set up our equations. So P1V1 over T1 is equal to P2 V2 over T2. And basically, we're just going to plug in our values here now and solve for our unknowns. So we've got 100 kPa, we've got 12.0 liters, we got 298 Kelvin down here, and then P2 is 50.0 kPa, V2 we don't know, and T2 is 273 Kelvin. So if we do this calculation, we get a final volume of 21.9865 blah, 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 which rounds off with significant digits to 22.0 liters or 22.0 decimeters cubed. That's it then for this video. Let's move on to our next task.